Hey everybody. So I'm gonna do another one of these programming Sunday challenge streams. I had a vacation, which was pretty neat and unusual. So I had a vacation, and while I was there, I played a bunch of old flight sims, and it got me thinking. Tiny Combat actually uses two different flight models. There's one for the player and one for the AI. I separated out because the AI, the calculations for the AI to use the player flight model was just too heavy. So I had to write something simpler. And it had to be something much more controllable. By coincidence, it ended up feeling a lot like Jane's. And it got me thinking that I really want to separate that out and formalize it because it's neat. And it's the kind of thing that I'd probably reuse for other projects or other random things. And I'm sure other people might find it interesting as well. So I want to try and make something like the Jane's flight model. I do have my code for that flight model, but it's steeped in a lot of tiny combat code. It's not the easiest thing to pull out. Plus, I think it'd be more interesting to kind of just write something from scratch and show everybody at least the thought process, because I think there's a lot of interesting details to writing this kind of thing. And honestly, I think it's harder to write a fun arcade flight model than it is to write a realistic one. So, to get a baseline, I want to use Jane's, and I do have it. So, let's jump over to that. So the cool thing about Fighter's Anthology is that it actually runs totally natively on Windows 10. Alright, that should work. Yeah, there we go. So I was actually playing this just before the stream because there's a lot of things to look at. Jane's is an old flight sim from the 90s. This is Fighter's Anthology, which is really nice because it actually just runs on a modern PC. You don't have to run it through an emulator or DOSBox. Well, it's too new for DOSBox, but you don't run it on DOSBox or anything like that. So it's really easy. But there's a lot of things that are interesting to keep track of with this game. Um, I want to. It's a good benchmark too because it's really responsive. I'm flying with a joystick right now. It's really responsive. It's easy. It's very precise. And but you still have things like gravity. Like if I dive here, my airspeed starts to go up, or if I climb, my airspeed goes down. And you also do things like you turn, you lose speed. And I have theories on how this might work. I think a lot of it's based on this G meter. The way that it's so prominent makes me think that it's the driving force behind all of it. This little flight envelope window, this is from Chuck Yeager, but this little flight envelope window also makes me think that a lot of it's based on G, because you have a little G thing here. And I think that shows... No, that's your current G. The other thing that's interesting about arcade flight models, and Jane's is very much arcade, is how do you handle banking? Because if you just naively, okay, you turn like this, something has to happen. Because with no physics, all that happens is the plane just sits on its side. But something has to happen. In real life, something does happen. And what other games like Ace Combat will do this. Jane's, I think, maybe does this. I'm not totally sure. They'll kind of artificially rotate the plane so your heading actually changes, so you can bank. And a lot of older sims do this as well. Like, I've been posting a lot of pictures of F-19 and F-117, and in those games, banking just kind of automatically changes your heading, and you don't really have to think about it, which is a good thing. I don't want to have to think about it, because most people who play flying games, I think, don't want to think about it. I have a suspicion, though, that the game or the stick is always commanding 1G, because something weird happens when you go inverted, and it's that you're still at 1G. Even when I'm sideways, I'm still at 1G. When I'm upside down, I'm still at 1G, which is weird. The only way to make this read -1 is to actually go inverted and pitch up, which is a little weird that you have to do that. So you're kind of fighting it. So I think there's something tricky going on here, but I don't know. This is just a reference. The other thing that's an arcade flight model has to handle is how do you stall? Because stalling, when there's no physics, you can't stall. But you got to do something to stop planes from just sitting in midair. So what Jane's does is there's kind of two stages to it. You have this little caret here, that this is your stall speed. And stall speed is kind of almost a made-up concept, but it's a convenient thing and it's mostly right. And so you have this little stall speed, and when you get close to it, your flight path marker starts to dip. And so you're actually kind of, if you try and go level, you're actually going to start falling. But the nose doesn't move, which is interesting. You're still flying level, but the nose is level, but you start dropping. And then, once you get slow enough, then it actually stalls. And I think it just magically pushes the nose down, because you can't really fight this unless you speed up. And that works well enough. So, let's go back to Unity. All right, now I have a little chance to kind of catch my breath. Go look at some comments while I'm here. Saw you, Wedge One says, saw you tweeting recently about USAF or another older F-117. So that's not Jane's. That was F-19 and F-117, which are old Microprose games. They're from around the time of the early Jane's games, but they're more contemporary with Chuck Yeager. But yeah, I've been playing those. I've been hearing a lot about those games, mostly from my father, who has been fanboying about it for decades. And I finally got around to trying it, and it is very good. Discord server. There's no Discord server. Twitter account is the same name as here. You can just Google Y485 Twitter, and you're going to find it. Do you think I'd make a Discord server? No, I don't. I try to simulate legit physics doing real-time calculations of lift. Based on airfoil lift coefficient, different AOA. Yes, I've done that. It's fun. But it will glitch out under certain conditions. I remember having problems too where at some it would get shaky, and in my case what usually ended up being the problem is it's actually realistic that it happens, but in real life you have other forces to counteract that. So like controls stiffening will stop you from pulling 30 Gs, which is physically correct at high speeds because it doesn't take much to generate a lot of G, but in real life you can't actually do that because you have G limits and it's harder to pull a stick and a bunch of things like that. Realistic physics, I've said this before, is a really deep rabbit hole, and I don't recommend it. Not if you can avoid it. So I do have something prepared here. I have this little F-16 model that I was going to use for something else, but here it is. This is not the Tiny Combat F-16. It's actually even lower poly than the Tiny Combat F-16. And a little terrain. There is some code. It does do something already. So if I hit play, it moves forward. But there's no way to control it. So it just goes forwards. So first order of business, I need to get this turning. And there's two, I was thinking about this before the stream. I think there's two approaches. I think there's two approaches to doing this. You can do it with some kind of physics, not real physics. I don't want to use rigid body real physics. But if you use actual like force equals mass times acceleration, I'm not sure if I should do that. I might. It depends. But rotations are more flexible. So I'm just gonna do something real simple. Let's just have a fixed pitch rate, which I don't know, 30 degrees. And roll rate. One thing that I like to do, and you should do in general, is separate out. I don't need to do it because this is such a demo-y thing to do, but it would hurt if I didn't. I like having container classes for controls. So I'm going to have this little class for pitch yaw roll. You're going to need a throttle too. Let's default it to, default it to 1. And do I need a vector 3? Sometimes it's really easy to convert these to vectors, but I think for what I'm doing, I won't need this. I'm just going to leave it raw like that. So here we go, flight input. Do I want this? Oh, I want this serializable so it shows up in the... I want this serializable so it shows up in here. Oh, yeah, that makes sense. I was just setting control. Oh, yeah, setting control surfaces. So, yeah, one of the many... It's interesting because the thing with realistic physics is that if you give it unrealistic input, it's not going to behave right. Or it's going to behave right, but not the way you think it will. Because in reality, your input is different. I need to read input somehow. So, like, if your control surfaces are moving instantly, it's gonna be weird. It's gonna feel bad, even though physically it'll behave like if control surfaces could move instantly in real life, it would probably be something like that. But they don't, so it's kind of funny that way. I'm gonna put some handling for player if this is a player or not. I don't plan on writing AI during this stream. There's not enough time to do that, but would I do this? Because this is code that I plan to reuse myself. I don't know that I would... See, I wouldn't do it this way anyway. I would probably have some other place handling input. So for now, I'm just going to assume this is always the player. But I want to get player input. And I'm just going to use this simple, just in the standard Unity input, because the new one is interesting but not ready yet. Okay. Horizontal is going to be your roll, and then your pitch is going to be vertical. And roll is almost always backwards, but I don't want to invert it in the input phase. So now, let's see. And I want to do this without physics. I always use rigid body physics, but I want to write physics by myself for once. Using rigid body physics makes a lot of things easier, but also makes a lot of things harder. I also wonder... I have thoughts about running this kind of gameplay code in update as well, but this is not meant to be super strenuous, because you want things to be as deterministic as possible, and doing it in fixed update would make it more deterministic. But you'd probably also want some kind of interpolation or smoothing. Anyway, let's get this rolling. I'm going to need, let's see, a pitch rotation. Quaternion. Oh wait, I don't need new. Goal axis. I want to rotate as much degrees as the input. So I'm going to command this much at this pitch rate, and with delta time, and I want to pitch, so that's going to be vector 3 dot right. I could probably do roll, but I want to do just one axis at a time. So let's do local rotation. Multiply the pitch rotation, and it's already handling for delta time. I think this will work. Let's see. So now it should just pitch up or down at some fixed... Oh, I didn't even give it an airplane. Here it is. So it should go up and down at some fixed 30 degree. And yeah, look at that. So it's just rotating. Let me make sure, though, if I set this to fly right. Okay, yeah, axes are still correct. And now I just want roll, which is going to be pretty much the same thing. Rotation, but roll and roll rate, and roll is usually has to be reversed, and it's around your forward axis. So this should roll now. All right, look at that. We're already done. This is with the controls just raw inputting of the turn rates. So, I mean, honestly, like, most people don't even notice anything about airplanes, so this is probably good enough. If you have a super arcadey thing, this is probably good enough. There's no speed control, though. I'm just flying at a constant speed. I'm moving forwards. It's taking velocity, not magnitude. I think it's just taking the start speed. Yeah, that's just the start speed. The velocity it sets to just forwards times magnitude. Alright. Oh, I need yaw. But those aren't bound to anything. So let's do this. Use the good old input system that's not good, but it is old. And I'm gonna trust that the third axis is the triggers? I think. Let's see what happens. This is going to be the same. But this is going to be yaw rotation. This is going to be yaw. And I don't have a yaw rate. I need to add that. And yaw rotates around your up. Yeah. I'm making gestures with my hands that you can't see. Yaw is usually something really slow. Let's just do 5. Oh, and I want to, oops, and I want to apply that rotation. Did I accidentally delete yaw rate? I did accidentally delete it. Oh, I need to read the input. I'm not reading the input. Yaw is the yaw axis that I just made up. Let's see if it actually went through. It'll complain if it doesn't, if it didn't go through. It's going. It's doing something. Am I commanding full left? I am commanding full left. Why? Where's that coming from? It's probably one of the joysticks. Oh, geez, there's too many joysticks. I don't know which one it might be. Is the throttle on one of... Oh, it was the throttle on my VKB stick. I wonder why the Logitech one doesn't trip it. Oh, this needs to be reversed. Alright. But it does work. I can yaw left and right. Can you reuse some source code for Unity? Code available on it online. Well, okay, so you can use stuff from the asset store, but I have never had a good... Okay, I could probably count on one hand. I could probably count on one finger? 2 fingers, maybe? the amount of code assets I've gotten from the Unity store and have felt happy with. I prefer to just write my own stuff, especially if it's something that I know how to do and something that I want to be done well, which I know sounds kind of bad, but I can reuse my own code, and I do reuse a lot of my own code. A lot of the stuff on my GitHub is on my GitHub because I'm constantly reusing it. So that's I reuse it when I can, and so like the guns and bullets. Here, this should work now. Although I want to bump this up to 10. I think 5 is a little too slow. Look at that yaw. All right. So if you wanted to role play, you could pretend you're playing like kind of banks into turns, but just yawing yourself. I'm gonna have to put a flight path marker. But I have raw turn rates, which is it's something, but it doesn't feel very good because it's really mechanical. There's no inertia to this. If you want to know how the AI bank, I know it's not an obvious application, but the way that it's done is kind of inside the freelancer flight thing. Because with the freelancer flight physics, the controller has to automatically bank the ship, and that's basically the same thing as getting planes to bank. I don't know. If I somehow manage to finish this in the next hour, maybe I'll try and do some simple planes because I think writing AI for planes is actually a lot of fun, but it's also very time consuming. And it's one of those things that I don't really have examples of except for the tiny X-Wing. But the problem I don't like uploading AI code is because it tends to be very specific. Am I going to upload the scripts to GitHub? Yes, this project will be... Yeah, I'm just going to upload this whole project to GitHub when I'm probably going to have to clean up some stuff first, though. So I have raw rotations, and that's okay, but I want to smooth it out a bit. And I think to do that, I'm going to need... Let's see. How do I want to do this? Rather than directly setting pitch rates, I want to be accelerating towards them. So you want to have a motion. Doing a lerp is the most awful way. Let's just do it in pitch for now. So I have my actual pitch, but I need a pitch excel. I wonder how James does this. How did I do this? I don't remember how I did this. Oh, I was using physics for rotations. Physics took care of it all for me. So let's say to reach full pitch rate, it's 1 second by default. And let's see. So what I actually want to do, instead of using the raw pitch rate, because this is like the defined pitch rate, I want to use... well, first I need a target pitch. This is... If I had no inertia, this is how much pitch I would get. I don't need delta time, because this is just a number. Okay. This is how much pitch I want. But I need to slide. And I'm just going to do a move towards, so it just... This is very linear acceleration. This probably won't feel very good, but it's I can, you know, it can be fixed later. I want to go to the target pitch and at the accelerations rate. Does this have to be multiplied by delta time? Yes, it does. Target pitch. So that's the actual pitch. So now there should be some inertia. I'm going to accelerate at 30 degrees a second squared, I guess would be the real number. There should be some inertia now. Ooh, but it stops instantly. There's inertia to pick it up, but not to go. And it's like absolute valued. When I pitch up, it goes down. And when I pitch down, it goes down. There's something weird happening here. This should be fine. Pitch starts at 0. Oh, because I shouldn't be multiplying by the pitch anymore. I was multiplying by the input again after doing that, so this should be good now. Yeah, there we go. That feels really heavy though. An F16 would be much tighter than that. Let's do 60. That's got some heft. You know, honestly, this feels like a space sim now. The linear feels bad. Like it works, but it doesn't feel great. Alright, I'm gonna set the default to 60. You know, the funny thing too is that I think Jane's has more in common with a space sim than it does a flight simulator. I don't remember if I said this earlier either, but I don't think how do I phrase this? Jane's is a lot closer to Ace Combat than I think people would ever admit. Because its physics are, like, the game really honestly does feel more like a space sim than it does a flight simulator. What Jane's does super well is it has the presentation. It nails the presentation so well that it makes you think it's a flight simulator. But it's super not. I wonder if there should be normalized values instead of values like this. I don't know. I don't know what a designer would think. So basically, I'm not using Unity's physics. No, I'm not using Unity's physics. I always use Unity's physics, and it's such a cop-out. I want to do it myself for once. It would be more portable to other engines, although I have no intentions to use other engines, but in theory it would be more portable to other engines, plus it's easier to be deterministic and precise about things because tying to the physics engine, oh gosh, it creates a lot of complications. Using Unity physics makes things a lot easier, but also makes things a lot harder. I wonder if I could generalize this to something. But I'm only gonna do this once. I need values. This should not be public. I need for roll and yaw. And these are your like actual tight. Why did I call that void? Your actual instantaneous values for this stuff. Target yaw, yaw excel, and then times delta time. And then, oh, that's this rotation. That's this one. And I don't need this input, and this should be yaw itself. And then for roll, this is very repetitive code. You could probably... I think in the free space source code, they have a function for doing the rotational code. I don't want to do that, though, because I feel like I'm going to need specific... I'm going to need to handle specific things. So when I get this out, I probably want to invert that. Do I need delta time? I do need delta time. And I don't want roll rate, I want roll. Roll. This looks good. Let's see. Please show us the aerodynamic script. Well, I mean, I guess this is the aerodynamic script, at least for this. If you mean for Tiny Combat, it's basically simple wings, but there's just some extra stuff in it. Whoa, okay. This doesn't feel like an F-16. An F-16 would be a lot tighter than this. But this is... Wow, this is pretty good. I want to use a better lerp, though, than just linearly accelerating. I don't know what else to use, though. I think free space does something with like natural logarithm for this stuff to get this feel. This honestly, this already feels pretty great. It just doesn't bank though. But I think that means one of the goals is done. Bam. So turn rate and excel. That's good. If you want to see the scripts for the aerodynamics for Tiny Combat, like honestly, the whole core of it. Oh, why does that feel bad? What if I raise the acceleration? Oh, it is 30 here. Ooh, that's tight. Okay, there we go. Honestly, the Simple Wings code, the Simple Wings project is where most of the Tiny Combat feel comes from. Like, the Harrier in Tiny Combat is just, it's just a bunch of wings. I think I've shown it before. I think I have a screenshot of it. I don't want to open the project because it's a big project. Did I take a screenshot of it recently? I don't see it. Was it last month? I know I took a screenshot of it like very recently. Here it is. I mean, so the Simple Wings project is on GitHub. Just search Simple Wings GitHub. It'll probably come up. Like, the Harrier is just made out of these Simple Wings, and that's honestly where 90% of it comes from. Like, that's the main wing. I think these are flaps? Yeah, I think these are flaps. That's the ailerons. That's the speed brake. Your rudder is back here. It's just wings. I actually made up control stiffening code for Tiny Combat, and I rolled that back into the GitHub project. So that's in the GitHub project too. And that's where a lot of the... Actually, somebody mentioned the shaking, or that it glitches out. And I was having a problem with that too. And just adding control stiffening made a huge, huge, huge difference. It also stops you from pulling like 30G at high speeds. Hey, you know what? This already honestly feels pretty good. I think I'm gonna need to do a HUD though. Is smooth step frame rate independent? My problem with that is I don't think it's... Is smooth step just a shader thing? Oh, smooth step. What's the difference between smooth step and lerp? Functions interpolates between min max with smoothing at the limits. It's basically lerp, but the problem... Can I use that? This wouldn't be frame rate independent, though. What are the inputs from and to? So if you wanted to use it, it would be like move towards current would be pitch. I still want target pitch, but I need a rate, and it would be, oh wait, that's move towards. Same thing. Pitch, target pitch. I get a feeling this isn't frame rate independent. I'm gonna try it though. Just out of curiosity. What's my frame rate? Alright, this is at 1300 frames a second. You get pretty instant... Wow, that's instant in the roll. What if I do half and roll? Oh, that feels... Why is it so weird feeling? Did it apply to the roll? Roll smooth? Yeah, that's there. That's weird. Oh, wait, okay, yeah. But if I lower the frame rate, put VSync on, it's still super fast. But let's do 30. This is something I always, and everybody should always do. Test your game at different frame rates. It still feels instant. Oh, it feels totally instant, though, in the pitch. It wasn't like this before. That's like instantaneous, even though it's the same settings. Yeah, that's no good. I'm gonna go dig through some of my code because I think I do have a... I'm pretty sure I do have a frame rate independent smoothing. And I use it for a lot of things. It's probably in one of the open source projects too. Let's see. Here, Smooth Damp by Rory Driscoll. Here. Oh, it already did that. I think this is... This should work, I think. Pretty sure this is frame rate independent. I've used this for a lot of things. Target speed, which would be this. Oh, I just need a... Oops. One of these guys. Okay, let's try that. I don't know. I'm curious what this is good. These numbers are probably going to be way off. Let's see what this feels like. This should be good, though. Oh, it's too fast. What about 5? Ooh, yeah, that feels good. Heavy. Yeah, the numbers are smaller. I'm not sure. Yeah, that feels good. There's some. Look at that. So I'm holding. I let go. Ooh. Oh, the power almost went out. I need to lower this. It's like divide by 3 seems to be the trend. Roll is still too fast. I don't know what these numbers mean. I'm just gonna do 10 on. But yeah, that feels good. Let's go a little bit lower. Yeah. Maybe a little too slow for an F16, but that feels nice and weighty. Ooh, look at that. And okay, pushing, let go. Push, let go. That feels good. Man, this is already like halfway there. I think I'm gonna need a HUD though. Because the part that worries me is how I'm going to handle speed. Turning, I wasn't. Oh, yeah, that feels really good. But these values are really weird. So pitch rate of 30 degrees a second, which is actually really fast. 5 feels good. A roll rate of, let's do 90. Something a little more normal. Actually, 90 is kind of slow. Let's do 120. That feels about right. And yaw. That's a pretty strong yaw. Let's do a little bit stronger. A little heavier. There we go. Alright, I like these numbers. I'm going to make them new defaults. So we have 35, a roll of 120 degrees a second, and an acceleration of 5. Although I'm not sure. I really honestly don't understand what those numbers mean. This smooth damp thing, I've been using this for a long time. I really don't understand how the math works, but I use it all the time. It is frame rate independent though, so this is. All right, let me change this, update this. So I'm running at 30 FPS now. I'll just do a sanity check. So this is 30 FPS. That feels good. And now let's do 1,000,000 FPS by turning off the. Where did I put it? Oh, yeah, that's right. It's permanent. How do you make target frame rate infinite? Is it like -1? What does the documentation say? -1. Yeah, I think -1 is infinite frame rate. I mean, it's that easy, right? Yeah, look at that. 1,300 FPS. And this still feels, yeah, this still feels right. Always test your game at different frame rates. Please don't make games that run bad at high frame rates. Yeah, this feels good. I like this. It doesn't bank though. Like I bank, but I just keep flying straight. Look at that. That looks pretty good. The jets always feel so slow in this game. I assume you mean Janes, and oh man, Janes, yeah, they do feel really slow. I have a lot of thoughts on that actually. Jane's has a very, very, very warped sense of scale. And I want to say it comes from technical limitations because I think it's an evolution of the same engine in Chuck Yeager's Air Combat. I want to say it's based on engine limitations, but it's interesting. And honestly, I think the game's better for it. Because it's also why the game feels so much like a space sim. The ranges are so much well, they feel a lot closer. So when you get in a dogfight, you see the guy you're shooting at, and you shoot your giant, like, MiG-21 sized bullets. And when they hit planes right in front of you, and they explode into pieces right in front of you in a way that you can't really do with realistic scales. It's interesting. I like it a lot, but it's definitely odd and takes some getting used to. I think I might play the game a little more later just to show the way that looks because I think I might try to do something like that. I wonder if I can add a scaling multiplier to these physics so that you can run it at like half scale. That way the plane acts like it's flying at 400 knots, but it's in reality, quote unquote reality, it's flying at only 200. You should get that same effect as in Jane's, where you're like flying and you can see what you're shooting at. A lot of old games did that. And I think for technical reasons, because when you're running a game at 320 by 240 or 640 by 480, you can't really see a lot. This feels really good. I'm just flying around, like having fun now. When you're running at that lower resolution, you kind of need to have things scaled up. But it had a really interesting consequence on the way those games felt and played that it'd be hard to convince somebody to do a game that way today, but I think it would feel really good if you did. This is neat. I like this. All right. What's next on the list? G limited turns. Thing with G limited turns is I need speed control. I need to be able to go fast. How am I navigating Visual Studio in a Vim-like fashion? There is an extension for Visual Studio called VS Vim, and it gets you. It's basically what it sounds like. It's Vim style commands for Visual Studio. I will not use a code editor if it doesn't have a Vim plugin. All right. I think I need some kind of HUD now because this is. Should I do a HUD for real or like a debug text? Honestly, debug text is so hard to draw in Unity that I might just do a real HUD. Why is there not just some easy way to print text to the screen? That's whatever. This is the world we chose. All right, I'm going to make a really simple HUD. Actually, I want to pull up that font that I found. Actually, I made. What did I call it? No, because then I'm going to get anal about pixel perfect fonts, and that is a. I can't keep doing that. But I'm going to use a custom font because using aerial sucks. Alright, let's use this. I need... So I guess it's going to be speedrunning a super quick, ugly HUD. All I want is airspeed and G. I don't need altitude. I'm not doing anything sensitive to altitude. Let's say that's... I probably need that many spaces. Anchor to the edge. This is going to be the HUD outline. Something like this. 400 by 300. That's good enough. I also want G. So 1.5. I'm going to do it like that. Sure. That'll work. Doesn't have to be great. Oh, let's do bold. Should there be a space after the G? Nah. I want to put a box. I want to put a box here. I also want a flight path marker too. Oh, I shouldn't have started doing this. Oh, okay. But I need a script for the HUD. So the HUD. One of my favorite dirty hacks is just having a public static thing. So let's say this is the player. So what this does, but I need to know it's the player, because what if there's another plane that's not the player? So as soon as this wakes up, player is this. So then in other places in code, you can just do aircraft.player, and you automatically have the player aircraft. I do this more often than I'm going to admit. So I then in the HUD, I'm going to use the UI as well. So here's the I need what, airspeed and G. Airspeed and G. And in the update, I'm just gonna get the player like this, aircraft.player. In reality, you may want to check if that's null. I probably should, even though... Because there's no guarantee that there's a player. Actually, before I forget, let me check that to make sure there is a player there. Also sets it up so you can do AI later. But, okay, so airspeed, I'm going to read... What's the conversion for meters a second to knots? Let's see. Oh, I want to have a... I like doing conversion classes. So 2 knots. And the conversion is 1 point this number. And I don't need to do other things. I'm not going to worry about it right now. Two knots, and I need the player's speed, which is going to be that. Why is it not? But I want it to string like that. Man, that's UI is always gross. And I also want the G readout, but I don't know what my G is. I haven't calculated that. I have that saved because that's a whole function. That is here, this thing. I was going to copy this class. This code is, I'm pretty sure this code is also in one of my projects. This will calculate the G, except I'm not using rigid bodies. So I need to change this. What I actually need is... I need the velocity and angular velocity, which is vector 3, right? What's angular velocity? On my second monitor, I have the Unity docs open up. Angular velocity is a vector 3 that I'm assuming is pitch yaw roll. Oh, tricky. Angular velocity is in radians, not degrees. Wait, that was over here. Let's see. Velocity degrees. I'm going to do the conversion in here. Because it's in degrees, but I need it in radians. Because that's how it originally worked. Why did I put a comma there? Why? Why is that, I guess it doesn't know what it should be. There we go. And so this is velocity. Why was it expecting... Do I convert? I guess I just always assumed it was in radians. I mean, it did work before. I mean, That's interesting. I don't even make note that that was supposed to be radians. I guess the math works out that way, and it assumes that it needs to be in radians anyway. I think it's because the G math has to do with circles and radii. Interesting. But hopefully that works. So G is player dot. I don't have an angular velocity. Ah. If this was a rigid body, I could just pull this. How did the original math work? What did I do with the rigid body? Just this. So I convert it to local angular velocity. Because I think I only wanted... Why? Because I think I only cared about pitch. Because I don't measure G in the lateral or anything. So I think all I need is my pitch? Do I use local angular velocity in any other ones? I use only an X. Degrees to radians. And then I don't need this anymore because I don't actually use it. I should just say pitch rate. I don't know. I feel like the negative is going to be wrong here. Hopefully this works. I don't know if this is going to work. But I need to make the pitch accessible. Let's see. I'm just going to make this public. Wait, I can't do that because that's over here. I'm going to rename these. Max pitch rate. Because these are ideal maxes. So I can call this pitch rate. Oh, Shazbot. I should have called this. That's what I meant. Something got screwed up. Here. This should be max. Oops. Max yaw rate. I think that's the only thing I screwed up. Roll, 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 roll. Yeah, okay. That should be right. This is C sharp. Between C and C++, I prefer C++. I think C is kind of a meme at this point. There are extremely specific... I don't know. I don't want to get into this rant. Yeah, this is Visual Studio. Visual Studio, C sharp, on Unity engine. Unity uses C sharp for its scripting. Yeah. I'm just going to make these public. Oh my gosh, I actually really want to learn. I actually did spend some time a few months ago setting up a Rust development environment and all that. Rust seems really neat. It's very ugly, but it seems very neat. Yeah, eventually at some point. Oh, Bevy, yeah. Bevy was the thing I was looking into. One of the many Rust things I was looking into. I don't think I actually did one of the tutorial projects for it. I did try... I loaded the samples for another Rust game engine. It might have been Amethyst. I really want to do that stuff, but I don't know. When I have time. Maybe after I finish Tiny Combat, which Even that seems like a fantasy. But I want the pitch rate, and I want to do calculate pitch G. I need the player transform. I need the player velocity. And I have the pitch rate. That'll give me G. This is kind of dopey to do. And then, oh, look at this string interpolation generating tons of garbage in a prototype project that doesn't matter. That might work. All right, add the HUD. G is G, airspeed is airspeed. Let's see if it crashes. That's a little too precise. What happened to my pitch rate? I can't pitch. Can I yaw? I can yaw. I broke pitch. Uh-oh. I think I know what I did. I think max pitch rate is being used somewhere it shouldn't be. Move. This should be pitch rate. Ugh, pitch rate. Okay, now it'll work for real this time. Oh, but that reminds me, I want to fix that G meter. It's super ugly. In the HUD, I think you do it like this. I want 0.0 for my G's. Pitch is still broke. Oh, because it's 110. I'm setting pitch rate somewhere I shouldn't be. I broke something from refactoring too quickly and too hard. Max here, this. This should be pitch rate. Okay, now I'm not setting max pitch rate to 0. There we go. Hey, look at those G's! Oh, that's cool. 10G. Negative 1G. I mean, that's right. 389 knots. Why is it negative 1G? I guess 0G because there's no vertical component to it. Man, this is so like simple, but it's already pretty good. See, so if you are making like an Ace Combat, a game where you don't need to land, like this could be enough. This is probably enough. You could make this actually really good space sim physics. If you tied the pitch and pitch and yaw together, so you get this kind of effect. Let's say, what's half of 120? 60? So if you did this kind of thing, whoa, that's too fast. That's really fast. Look at that. That's basically space sim physics. But that's... Man, that's pretty good. But I want G limits, because I notice, because Jane's seems to... I think Jane's has 2 limits. I think it's a G limit, and I think there's also another one. I think you just hit a max turn rate, and you just have this ideal turn rate. And then whatever your final turn rate is the max of your... either the turn rate or either your turn rate or your G, whichever one it hits first. So in most cases, you're probably turning at whatever your max turn rate is. But if you go too fast, then you hit max G, which is something you have to be careful of because some planes in Janes are really fast. And if you're just going afterburner all the time without thinking, you can get G limited and end up taking really long to turn, which is really cool. That's super interesting, and that's fun and makes you think. But it still plays like Ace Combat, even though people who like Janes won't admit that. It really is. Janes really is only a few steps removed from Ace Combat. Man, this feels pretty good. See, this is why you shouldn't make games with physics. With real, like... Don't make realistic games. Realistic games suck. Do as I say, not as I do. Man, I get distracted just flying around. Because it actually is pretty fun. Alright, so now I have a G meter. Let's see, how can I do G limited turns? Because now I have a G readout. And in fact, I'm just going to make it something that you can read. Pitch G. And as part of the flight model, I want to... I guess I want to do it after I do the rotation code. So pitch G is going to be my flight calculator, calculate pitch G, my transform, my velocity, and my pitch rate. I'm surprised that worked. And somehow I need to limit it. Wait, what? So yeah, I was looking at the flight envelope window, and it's really cool. I don't really understand how to read it. I see how it reacts to things, but I'm not really sure what it means. It's been there since Chuck Yeager. It is a really cool thing. Whatever it is. I'm also pretty sure it's exactly how the flight model works. Like, I almost want to say there's some lookup tables for the flight model. And, like, that graph is just exposing those lookup tables, which is really cool, but I don't know how to read it. But what are you getting? What is it showing? Because I know x-axis is speed and y is altitude, but I don't know what the colors mean or what they do. I want to say it's like your max G, but I'm really not sure. Okay. So I have pitch G. Actually, it looks like it's gonna always be one frame late. My idea for limiter. So my idea for a limiter is just that it reduces... maybe I need to do this backwards. Calculate what the max rate you can have at any time. I'm actually not sure how to calculate that. Have something that gives me G. And I want... the reactive way would be... let's see. It's gonna be 1 frame late if I do this, though. Which means it'll probably overshoot slightly. Well, let's do this the dumbest way possible. Just to see what it does. Pitch multiplier? It's not descriptive. If pitch G is greater than... Oh, I need a G limit. This thing was pulling... Let's do 7 Gs. That's a reasonable limit that I know the plane will hit. If it's 7 Gs, then it's 0. Otherwise, it's 1. This is going to feel bad, but I want to see what this does. So basically, if it goes over 7, it stops applying pitch. Let me call it G limiter. Now you're making me think about how fast it compiles. And I'm not sure if it's compiling or not. Hey, that actually worked. That's weird. That shouldn't work this well. Oh, there needs to be a negative G limiter. There definitely needs to be a negative G limit. This shouldn't be working so well. I'm very suspicious. This might not... I wonder if... This isn't right. This can't be working this well. I wonder if I put it at 30 frames a second, it'll feel bad. Because it can do that limit. It's bouncing between that limit, like, at 1,000,000 frames a second. See, you can feel it. You can feel it kind of juddering slightly. This is what I was expecting. Actually, let's go even lower, because the frame rate affects how precise the G limiter can be. So at 10 frames a second, this should feel terrible. Oh, this feels bad regardless. Oh man, this feels bad. This is F19 on 3 megahertz computer. Look at that. You see the G? It's bouncing between like 4 and 7. And it's like, you get a really nasty stuttery turn. So as long as your game is running at like 300 frames a second, it should be okay. Ugh, this is a bad solution. It's reactive though. I don't, that's by its nature, that's gonna happen. You know, I bet this happens in Tiny Combat. No, does it? I don't know. Well, let's just say there's a reason the Tiny Combat physics frame rate is like 120 hertz. Did you try Overg Fighters? Yes, it is. Overg Fighters and Energy Air Force is one of my favorite 360 games of all time. It is horribly, horribly underrated. And it was very, very misunderstood when it came out. Which I can understand why. Because I don't think anybody expects to play something that is basically a 90s PC flight simulator, but on console. Like, nobody really expects to play one of those on console. But they made one, and they made one for PS2 as well with Energy Air Force. And they're really good. They're really, really good. Well, okay, there's a lot of qualifiers that have to go with that. But mechanically, they're very good. And they are such a perfect mix of simulation and not arcade. Yeah. Overg was actually one of the main inspirations for Tiny Combat. Oh, this game has had so many inspirations at this point that it's just a giant melting pot of simulations. I wonder if when I'm done with this game, I won't ever want to touch another flight simulator again. That's probably not true. I don't want to leave this. It kind of works, but it feels bad. The right way would be to predict what the max pitch you could possibly reach at this speed is, and then cut it off there. You could also probably add a, let's see, like lerp something. So let's say if you're over 1G, it'll, how would you do this? I need something that goes, I need an inverse lerp from my current G plus to, let's say, 1G. So that'll be 7. So 8 would be the true limit, even though 7's the G limit. And then your G limiter would be a lerp between 0 and 1. I should probably put debug text for this because this might not be right. Wait, I want the G limiter to be this thing. And then I want to see what the value of this is too. Let's see. This is, I don't know what this would smooth it out. It'll make it feel better. Oh, it's 1. It's 0. I think I should. I think I have this backwards. Why is it 0? I think I need to do 1F minus. I need to invert it. So I have 1. I'm gonna go up, and it should slowly limit me. It's not at all. What's it actually doing? Wow, it decreases fast. Okay, there. Let's see what it's actually doing, because that's not what I think should be happening. Okay, so it says 10G. So what I got 0. Why did I get 0? Because I'm at 10. No, I want my, yeah, I'm not doing this right. This should be max G. This should be from G limit to G limit plus 1. I did that backwards. What CPU am I running? It's an i5-90. I don't remember right now, but it's very fast, and I upgraded very recently. Hey, look at that. That's smooth. Look at that. It's rock steady. But it is slightly more than 7G, which is kind of what I would expect. And you know what's interesting? Nothing in Jane seems to hit a exact G number. I might be talking out of my ass. That might not even be true. This works. It's not exact, but it seems to work. I can do 7.4G when I'm pulling up. 7.3. Ooh, 7.2. Interesting. You know what? You should be able to slightly over-G your plane. That's exciting. So, okay, so if I set the G limit as 9G, then what do I get? 9.2. It's always slightly more. 9.2. What if it's a 5G limit? 5.4. You know what? It seems to be more. Like if I do 3, it'll probably go like 3.9. 3.6. Those isn't going down. If I go up. Huh. This is not a good solution. What if it's a percentage? Instead of +1, it's 10%. Yeah, this will be posted on GitHub when it's done. I'll probably take some time to clean it up a little bit. Oh, look at that. That's very precisely coincidental. That's interesting. Is it going to be 5.3? 7? 7.3? 9? Is it going to be 9.3? That'll be precise. No, not quite. So this isn't perfect. 9.2, but it's closer for sure. What if a G limit of 2 Gs? That's like flying a 747. It's pretty good though. But does it feel good at 10 frames a second? I mean, nothing's going to feel good at 10 frames a second, but I hope it doesn't bounce. That's not. Oh, jeez, that's bad. It still bounces. Ooh, that feels really bad. Ugh. Maybe that's just a known limitation. I think the real correct, like absolutely correct solution is I calculate what the max pitch rate is for the G. And then use that instead. Because this is a reactive system right now. And because of that, it's always going to, by its nature, it's going to be bouncing against the G limit. It's kind of like a rev limiter in real life. Like, that's why they bounce, because they hit it, then they go over, then they go down, then they go up, then because they go, oh, I have space to go up more, so I'm going to go up. Then it goes over, then it cuts the throttle, then it goes down. So you get that bouncing noise. That's essentially what's happening here. I'm hitting a rev limiter with the G's. So you know what? In real life, it might actually work this way. But the thing is flight control software updates at the update rate of that thing has got to be at least like hundreds of times a second. Probably maybe 1,000 times a second. I don't know how fast. I wonder if you can Google that. What's the update rate of an F-16? There's no way I'm gonna get that. I don't see anything. I don't think it's that might not even be public. I might not be searching for the right thing. Because I think it's like the cycle, like clock speed, maybe? No, that also doesn't feel right. Somebody who knows. I bet you a control engineer could answer this question. Or at least know what to look up. I'm going to leave it as this. I'm just going to say it's a known issue. Maybe later I can figure out a better way to do this. Sample rate. Yeah, it might be sample rate. That's at least part of it. I mean, the thing that people always say is, oh, it updates at thousands of times a second, which maybe that's true. I don't know. I can't I can't waste time doing this. As interesting as it is to me. And it hits the rev limiter. Um, you know, I just. I know there's got to be a really easy way to do this that I just am not thinking of right now. Because this seems like one of those force equals mass times acceleration. You just solve for x or solve for a, and then you get the number. Because, I mean, what I'm getting is I have g, which is a result of pitch rate and turn radius. I think the problem is I don't know my turn radius. And I want my pitch rate. Wait, oh, let me see that code. But I can get my turn radius. Because what I actually want is my pitch rate expressed in G and something else. And my turn radius? I don't know the relationship between these numbers, though. My turn radius I could calculate with... No, I need G to calculate my turn radius. Huh. You could do like a... I can think of like a brute force way of solving this. A brute force way of solving this would be just calculating a bunch of numbers until you get something close. I know there's a fancy term for that, but I don't know what it is. This is what I'll probably have to do that for my... I'm going to have to do something like that for my CCIP indicator for the bombs. I don't know. I'll just leave it there as something to do. Because this works at normal situations. As long as you're not getting like 10 frames a second, you're okay. So, man, I haven't gone through this as quick as I wanted to, as I thought I would be. So there's your G-limited turns. Next on the list, gravity and thrust, which is basically speed. So things I remember from chains is it takes some time for your throttle to react. It's not a big deal, though. It takes some time for your throttle to react. Although the afterburner's instant, at least the visuals for the afterburner are instant. I think that might just be a bug. Because you will hit afterburner before your engine fully throttles up. But I need somehow, when you pitch down, you get speed. When you pitch up, you lose speed. Now, if I was doing actual physics, this would just be like a force equals mass times acceleration kind of thing. So the real question here is, how am I handling speed? Is speed... You know, I wonder if I ran this in fixed update, it wouldn't jitter like that. Because fixed update... Actually, I'm curious now. Let me put it back at 10 frames a second. But do it in fixed, because it should run multiple fixed updates to stop that from happening. Oh gosh, this feels really bad. Yeah, yeah. See, this is why you shouldn't use update. You should run all your logic at... this is... Gah. But to do a fixed update well, you'd probably want some kind of interpolation. This totally works, though. Yeah, that super fixes it. What does that look like? So if I do... See, but then because now... And I can see this on my monitor. That it's not perfectly smooth. I don't know. Yeah, you might want to separate... I don't know, that's getting too complicated. Definitely way too complicated. In general, you probably want to use fixed update, though, for any gameplay physics-like things. Let's see what else. I also want to do angle of attack and stalling. Angle of attack, you can't do stalling without angle of attack, because right now it is literally on rails. Which you wouldn't know, though. If you didn't have a flight path marker, you really can't tell that it's not on, that it's on rails. And the thing is, it feels good even though it's on rails. Oh, I should put a negative G limit. I don't want to do that. Oh, I should do it though. For completeness, I think 3G is reasonable as a negative limit. So if pitch is positive, then you want to use... Actually, you want to use that. If it's negative, then you want to use what? G negative limit? Minus? I think this is what I need. Unity compiles so fast that... I think this is honestly a really bad habit. Unity compiles so fast that I'll just type code and not really think about it. And just hope it works. Because it compiles so quickly that... Why is it 5? It is G-limited, but it's 5. Oh, that's why. That I'll just write stuff, hope it works, and then see if it works. Yeah, there you go. There's your negative G limit. Man, how do you hit 7G so easily at 300? I guess 389 knots is nothing to sneeze at. Oh, you know what would also be nice? To show the actual pitch rate. Because then you can see there should be like a corner airspeed kind of thing that naturally comes out of this. I don't think many... I'm not sure if any planes actually have one of these. An instrument that shows pitch rate. But it'd be really interesting to see. Do I want... How many... That's probably enough precision. I'm actually not sure what this is going to look like. Oh, I should negative it. Invert it. Negative it, yeah. So let's see. Ooh! I'm G limited right now. So even though my max pitch rate is actually 30, because I'm G limited, I'm only hitting 20. So I would want to... I can't slow down because I don't have a throttle, but... So you would want to slow down so that your G... You happen to be pulling 7G at whatever airspeed gets you the max turn rate. That's neat. Look at that. No physics, and you already get a corner airspeed just out of some really simple math. That's cool. Oh, this is why I have the fixed update in my game at 120 hertz. That's neat. But I'm not sure how to handle speed and stuff. What does Jane's do? Let's take a Jane's break. God, this game has the most 90s music. Okay, so yeah, talking about scale, look how huge. I think those are IL-77, IL-76s. Look how big they are. Everything in this game is humongous. Oh, the gun sounds different on the Draken. Pew. Oh, I think that was a war crime. IL-96. Look how big and slow everything is. You can see your giant bullets. And the hitboxes are unbelievably forgiving. But I don't know how the speed works. Oh, I can hear the explosions. I may have done something I shouldn't have on stream. You know, I wonder if this game actually uses, like, forces and mass and stuff. You could probably make that work. Although the problem then becomes, how does drag work? What is your, whoa. What does your drag curve do? See, it's never like a perfect number. Like the G limit on this thing is, if I go faster, I can get like 6.3. What if I slow down? Oh, I slowed down, and I can pull more Gs now. So this game does have some kind of control stiffening going on. Oh, I just hit another limit. Now it's slowing down. It slows down in such harsh increments. There's gotta be some lookup table or something like that. Wow, the Draken has good textures. Most Chains planes don't look this good. Wow. Oh, I'm gonna die doing that. I probably won't survive this. Woo. Oh wow, I actually got him. I didn't think they would hit. I got lucky. Those don't usually hit. See, this is what most planes look like. Hmm. One, two, three. It takes like 4 seconds to go between idle to full throttle. 1, 2, 2 seconds to go from 1, 2, 3. Oh, tricky! You can throttle down faster than you can throttle up. Because when you throttle down, it's usually an emergency and you want to have fast response. Oh, that's very clever. That's very clever. But I do wonder how... you know, they might actually be using forces. It wouldn't... That's not too far-fetched. Wait, how could they be from Strike Commander? That was a different company entirely. Was Strike Commander EA? That was Origin, and then EA bought Origin? Yeah, Jane's is EA. Man. I was gonna say, isn't it wild that EA used to make flight simulators, but somebody just tricked EA into making a new X-Wing versus TIE Fighter. I still can't believe that happened. I have no idea how somebody pulled that off. I would love to see a behind-the-scenes story on how they did that. It really doesn't make any sense. They're so obvious in the daytime. Oh, I can't even lock onto them. Wait, are they actually stealthy? Wow, I cannot get a lock on them. Oh my gosh, I didn't think that would work. There's one more. There he is. Look how much inertia that had. Like, I had to actually apply counter roll. I cannot lock onto them with anything. God, the AI in this game is so good. That's a good model. Nothing. See, this is what I'm talking about though. You can see the plane right there because the scales are so screwed up. And it's like you get so many guns kills in this game because it really is like just playing a space sim. Like honestly, X-Wing it's harder in X-Wing to get to get guns on target. Look at those hitboxes. Oh yeah, something else this game does is great. You can keep shooting something that's blown up and it'll blow up like another time. Look how many times this thing blows up. It's so good. Oh, I might crash. I think I might do actual physics. At least in some capacity. For the linear movement. That seems to be the way to go. And it shouldn't be too difficult either. Probably. Hopefully. The only thing is drag. Drag is gonna be probably a little tricky. See, it's always a weird number. It's 7.7. It's not 7, even though I bet the G limit's actually 7. Seven 7.5, 6.9, 6.2, 5.1. You can feel the like where it skips over to the next frame, the next data point. Oh, there comes a stall. Flight path marker drops, but the nose doesn't drop. Then you hit stall, and then the nose drops. And then you get a canned flat spin, which is pretty good. I remember this. Hmm. I think using actual weights is the way to go. The F-117 is probably the only plane with an actual polygon count in real life. 1, 2, 3, 4. No, 1, 2, 3. It's probably like 4 triangles here. In terms of faces, 1, 2, 3, 4, 5, 6, 7, 8, and then 9, and then how many for the wing? It's about 10 faces. You can count the polygons on this plane. I mean, it works in F-19 or F-117. All right, so I think forces are going to be the way to go. Oh, I got to take a stick off my disc. I'm not going to remove this. What I'm working on here has no bearing on the physics in Tiny Combat. Probably. Well, I can tell a dark secret later, but this has nothing to do with Tiny Combat. I'm not going to be changing the Tiny Combat physics to this. Let's see. If I'm going to do forces, I'm going to rename this. This is turning. Let's just call it turning. Forwarding, going forwards, linear. I don't want to call it linear. That's such a scientific term for something that's not. I'll make it a float, whatever. Mass. Mass. You'd think I would have the mass of an F-16 memorized with how many times I've looked this up. Let's see. Empty weight is 85. It's about 8,600 kilograms. But with fuel, it's about. That's another 3,000. I shouldn't have done that on a calculator. 11,600. Let's just do. That's about roughly a fully fueled F-16. Oh, that's a good idea. So, re-implementing Terrence, I want to look that up. What was the guy's name? OpenFA. That's a crazy thing to do. I can't find it right now, but I want to look that up. That's a cool, crazy thing to do. I wonder if you would be tempted to quote unquote fix anything. Like the scale stuff, which I have such mixed feelings about that. Because on one hand, I think it's brilliant. And I don't think the Janes would work. It would be a worse game if everything was to scale and planes weren't huge and all that. I think you would make it worse by making it better. Or at the very least, it'd be something totally different. What's the thrust of a F-16 engine? Man, I've written this down so many times. Like, this, I should have this memorized. Mill thrust is 70. Let's do a block 52. 79 kilonewton. I'm gonna write that down. Kilonewtons. And afterburner is 129. Huh. The GE engine is more powerful with an afterburner. This would also be kilonewtons. Oh, I'm gonna pretend to be British and call it reheat. I don't know what to call this. I don't want to call it linear, and I don't want to leave it as turning, but I don't know what else to call it. Okay, but this is all turning stuff. So let's refactor this a bit. Rotations. And then that just feels weird calling it linear. I remember thinking when Bring Your Own Battleship would stream, and I would think like, man, he takes a long time to answer comments sometimes. And I totally get it now. I'm just not looking at it for most of the time. Trying to program and read comments and stuff is pretty hard. What do I need? Well, I'm gonna need to use the throttle for a change. How do I want to manipulate the throttle? And I want like a heads-up display element for it, because I want to be able to see. Oh, how did Janes do it? I must have a screenshot of Janes somewhere. Here we go. There. They call it Thur. Afterburner. They put it over here, but I don't know, I'll put it over here. Let's use Jane's terminology. I think it was just a number. Oh, it was a number and percent with a space. I might be being too literal here. What else do I need? I have airspeed. I don't need that. Should I just copy the Janes thing and just put it here? Maybe I'll do that. At least the F-16. I know they kind of shift the HUD around a little bit. put this over here. So I want throttle. And throttle. Look at all this string interpolation. I'm going to... A lot of string interpolation going on. Throttle... Oh wait, no. I want... Thrust space percentage. But if it's afterburner... Oh, I don't have an afterburner. What's afterburner? Is there a 100% throttle in Jane's, or is it just afterburner? I remember the afterburner cutoff was really short. I'm not going to worry about it. Because that's not really that important. The physics is all the same regardless. And I now need a way to control the throttle. I'm using an Xbox controller, so I'm just going to have a... I'm just going to do the gamepad. Let's see. This is going to be a few things. Let me do it this way. No. If... Get button... 0? How does that work? I think it's fire 1. Right? Yeah. I need to check if it's fire 1. Yeah, fire 1. And then fire 2 will... Otherwise, you just want to stay at your current throttle. But it does that super neat thing where the rate of change actually changes if you're going up or down. So if you're going up on the throttle, it takes 4 seconds. So throttle speed is actually 0.25. But if you're going down, it takes only 2 seconds. So throttle speed is actually 0.5f. And then, if you're not doing anything, even though this is totally redundant, I'm just going to set it to 0. So, you're going to move at the target throttle. Wait. Current is that. And I'm going to target throttle. And my speed is going to be throttle speed. Delta time. So this is like a simple, you press a button, throttle goes up, press another button, throttle goes down kind of system. Oh, I need to clamp it. I didn't clamp it. Oh, I don't need to clamp it because it's doing targets instead. That's gonna throw an error. Yeah, throw an error. I forgot to assign throttle text. I should default to 100. Oh, okay, to 1%. Yeah, I gotta multiply. In the HUD, multiply throttle by 100. Oh, and it needs to be, there's no, yeah, there's no numbers after it. So here we go. This should do A and B. Look at that. That is really clever. I appreciate you, Mr. Janes. I forget his name. That's back when you could name the developer of every single... Like, most games had the developers, like the credits in the opening, because there were that few people who worked on games. Now it takes like half an hour to get through the credits of like an Assassin's Creed or Red Dead. It doesn't do anything, but the throttle does go up and down. I mean, Jane is a guy. Well, I don't know if he's a guy. I'm assuming he's a guy. There is a Mr. Jane who makes Jane's publication, right? Mr. Janes. I just typed Mr. Janes into Google. I don't think that's him. By Fred T. Jane. I mean, he didn't make Jane's Fighters Anthology, but he made Jane's. He's the Tom Clancy of flight simulators. That's not a good analogy at all. Iverson, that's the guy. Brent Iverson. He worked on Chuck Yeager, and then he kept on working on the Jane's games after that. I don't know what he did after Fighters Anthology. If he worked on like USAF or the other later ones. Okay. So what I want is to generate thrust, which would be your throttle times the mill thrusts, because afterburner is something different. Afterburner is special. I wonder how we would handle that. I have a couple ideas. So, if you have, let's see, that's your force, thrust force. I have my mass, because that's just mass. And so, what is it? Force equals mass times acceleration. I have mass and no. I have force and mass, I don't have acceleration. So... okay. You know what this isn't accounting for? Gravity. There's also no drag. I need drag. Equals thrust force divided by mass. So let's do thrust acceleration. I need an acceleration vector. Keep it a vector 3. Which is let's just pretend it's forward. It's gonna start forward because that's your engine. So that's acceleration due to your engines. But I also have acceleration due to gravity. Let's not do gravity yet. Let's just do this first. So now I have velocity is going to be... I should not calculate it. I'm not calculating. This is a bad way to do this. Velocity plus equals acceleration times delta time, but I want to straighten it out. Magnitude. So this is still on rails. It's just going to go on rails, but it's still going to use the velocity of the engines. There's no drag, so I'm just going to accelerate. I am just... oh, I didn't call the function. Did I? Huh? I should be accelerating. Or is there code somewhere else? That's unusual. Thrust force. Oh, because it's in kilonewtons. I think that's why. Because this number is way too small. Let's do it times 1,000. I think it's because it's in kilonewtons. Yeah, there we go. Look at that. That is a reasonable acceleration of a mil. Oh, I'm not going forwards. Oh, I'm like a camera now. Oh, this is not right. This is not right. This is not right. This is not right. Here. There we go. This should work. Oh my gosh, I'm using a velocity vector and it's totally not being used for anything. There we go. So look, 0 throttle. Don't accelerate. Mil throttle. Here we go. I mean, F-16s accelerate pretty quickly. This is with no drag whatsoever. I need some kind of drag. And drag is where it gets complicated, because I can never settle... I can never come up with a good drag model. Maybe I'll just use freelancers. No, that's a bad one. What's the real drag equation? Drag formula? Coefficient times density times velocity squared times reference area. Reference area 2? Oh, velocity over 2. So what I really care about is velocity squared. The more velocity you have, the more drag you get. And just some number? And it's always going to be opposite your velocity. So drag, it's just going to be a number. That's not capital. Is velocity squared and then something. And then what? Some number. It's just a magic number. Coefficient. Drag. I have no idea what this number should be. I'm just going to put 1. And then I need to apply... This gets you a force. I got that feeling this is going to be a big number. And then... So that's an acceleration, I think. And so you just want to subtract that by the velocity vector times the drag force, right? Because you want to go slow down, which is the opposite of your velocity. Yeah, that sounds right. I have no idea what one drag... Whoops! I went very, very fast. I think drag needs to be a very small number. What happened? What? Something happened on the very first frame. Velocity squared is a big number. Times drag, which is 1. So my velocity is 200. And then I'm adding 40,000 meters a second. I think I need to dial to time this. I don't think I ever played... I never played IAF, but I played USAF. Oh, that's still messed up. Okay, there's... Is the drag number too high? When in doubt, multiply by 1,000. Actually, no. When in doubt, add a PID, but I'm not in this. Whoa, that's a lot of drag. That is a lot of drag. Let's do 0.1 drags. I wonder what the top speed is. But if I let go, look at that, it's slowing down. This is how I used to make flight models for Tiny Combat. To find out what like top speed was, I would just set it and then set time scale to really fast. And then just see where it stabilizes, because eventually it's going to stabilize. Here we go, 10 times speed. So it looks like my top speed with 0.1 drags is about 500. Also, turning won't slow me down. Oh gosh. Oh no. Oh no. Oh jeez. So 509 with 0.1 drags. A supersonic fighter at Mach 2 has 0.016 drags. According to Mikkel Rasmussen. 0.016? I mean, these numbers are totally made up. That's probably going to be very wrong. This is very fast. This is nuts. That's very fast. Most planes in Jane's top out, like the F-16 in Jane's tops out at like 730. But that was a good guess. So 0.03. It should probably top out at like 800. You know, honestly, this might be just fine. Also, I meant mill thrust. I just realized. So this is a very super cruising F-16. Very super cruising. I think an F-16 can almost super cruise if clean. F-16s clean have like... They can do anything. They're like rocket ships. Let's try 6. I feel like a good max speed for a mill thrust F-16 should be like just under Mach 1. Which is 666. So this is just under Mach 1. It would probably go supersonic in a dive, which I bet you a clean F-16 could do. I think the Harrier can go supersonic in a dive too. That's a reasonable number. 0.06 drags. Plus it also gets divided by 1,000 anyway. 0.06. Wait, how fast does it accelerate though? Oh, it doesn't! Oh, because it's... Here we go. Oh, that's really slow. It should accelerate faster than that. I don't know, that kind of feels realistic. Kinda? No, that's probably realistic. Because planes don't really accelerate, like, super fast. And this is not accelerating at a slow speed either. Like, in real life, that's pretty quick. Okay. That's cool. That worked. Now I just need gravity. What happened to the two Who's? The plugin is kind of broken. There's some things I need to fix. They'll probably be back at some point. I had to fix Vim before the Visual Studio the Vim plugin for Visual Studio before the stream too. So that worked out well. It's going for light sim, so having sort of realistic accelerations is probably reasonable. Now I want acceleration due to gravity, which is just mass times gravity, if I remember right. Plus equals mass times gravity. If you want sideways gravity, it'll work. If you put 0 gravity, it'll also work. That's a negative number, right? Yeah. That should work. Mass times gravity. I'm curious what those numbers add up to. Wow, that's a big number. Gravity's giving you 112,000. I'm gonna assume that's newtons. While thrust is giving you 6. That's probably not right. Let's see what happens. I'm gonna fall very quickly. Look at that! Oh, here we go, frame by frame before it goes nuts. Ooh, 17,000. Gravity is accelerating me at incredible speeds. Looks like it topped out at 17,000. Yeah, that's not right. Yeah, this is C#. Why? Oh, there's something about the units here that's not right. I'm gonna divide by 1,000 and see what happens. This probably still isn't right. Still picking up speed by flying level. Oh, that's a heavy plane. Whoa! But if I die, oh man, wow. Oh my gosh. Oh, that's not right. That's really not right. Oh, it's like a roller coaster. Up, and here we go. This is really not right. Yeah, there's something. Why is that so wrong? I'm gonna look at this code really quick. I know this has gravity. Actually, I'm not sure it does. Actually, I'm not sure it does. No, it has to have gravity. How does the gravity work? I remember gravity work. Maybe it didn't. No, it has to. Oh gosh. Oh, I'm getting flashbacks to making this. Where did the gravity come from? It might have... Maybe it was just done with Unity physics. No? No mass either. I think it was just part of the Unity physics. I don't think I specifically calculated it. Which is weird, because usually I calculate gravity myself. Huh. Okay, mass is in kilograms. Gravity is in... That's kilograms, and I'm multiplying by meters a second squared. And the unit I want, because acceleration is meters a second squared. I needed, like, kilograms has to go somewhere. I'm not crazy, right? It is mass times gravity. Oh wait, that's a force. That's the problem. I'm not calculating forces here. I only need the acceleration. So if I was doing... Okay, here's the thing. If I was adding up the forces, then what I did would be correct. But I'm not adding up forces. I'm adding up accelerations. And the acceleration due to gravity is always going to be the... Oh, it's raining outside. It's always going to be the acceleration due to gravity. So it should be just this. Although, let me put a breakpoint again. But wait. It's not just this because I'm gonna always be accelerating. I think I do need to add the forces. This is not gonna work. This is not gonna work. I'm gonna accelerate. It's kind of working. You know what? It's kind of working. I'm not totally sure why. Why is it working? That's weird. Is that right? I mean, it looks right. But why is that working? Why is it working? I mean, that looks right. That really does look right. But it's constantly adding? It has to be with the way I'm redirecting the velocity. I'm very suspicious about why this is working. Why is it working so well? Oh, what's the corner airspeed? I should find that out. How the drag works. Corner airspeed is going to be wherever the turn rate max is. 17, 18, 19, 20, 30 is the theoretical max. It's still going up. Actually, you know what? This is going to keep going up. That's going to keep going up because there's nothing that slows turn rate until it hits 30. Yeah, see, it hits 30. When did it hit 30? When did it hit 30? It hits 30 at 270, 240. About it hits 30 at about 250. Well, a real F-16 could do 9 Gs. Although the Jane's F-16 only does 7 Gs for some reason. I don't know who did that. Let's put it on 9G. About 330 seems to be corner. Yeah, about 330. I think the real F-16 is like corner airspeed is about 400 knots. I don't know why that works. Why does that work? Oh, I know why it's working. I'm gonna have to fix this if I want to do like angle of attack. What's happening? Yeah, I know exactly what's happening. Is, man, it's cool that that just happens to work. Where's paint? Here's what's happening. So here's my plane. I have thrust giving acceleration in that direction. And then gravity is going that direction. Incidentally, gravity is actually more powerful than the engine. What's happening, though, is that I think I set all the all the acceleration only goes along the forwards. So the velocity, the actual velocity is somewhere down here. But then I multiply it. I think what's happening is this is getting canceled out. And it's happening because I do this, because I set the velocity vector to one direction. But if you're flying down, then it stops getting canceled out. It's kind of just a coincidence that it works. It's working for the wrong reasons. It'll work. I think I'll just leave it. Because it works for now. But it will have to be fixed. So that's kind of cool. Gravity and thrust is done. In order to do angle of attack, I will have to fix it. Because this is... Because I'm going to have to disconnect the velocity vector. But in order to get the velocity vector, I'm going to need to see a velocity vector. So I guess I'm going to have to make one. And I don't have a cool UI element. I probably do have a cool UI element somewhere. Let's see. Oh, I don't want to use a pixely one, though. Actually, I'll use the one from Tiny Combat. That one is okay. Probably. It's not perfect. But I guess I'll use it. Alright, so I need a image, this thing. What does it look like? It's fine. That's your flight path marker. This one's an image. It only needs to be a rect transform though. It doesn't need to be an image. And so the flight path marker is gonna be, ooh, I'm gonna do some bad code here. Camera dot main dot world to screen point. Wait, I need the velocity position, which is but like the world position. That's kind of a weird name. That's the player's position plus the velocity and then projected out, I don't know, 500 meters is probably fine. So what this is doing is it's taking to make a flight path marker, it takes the position of the plane. I am not factoring in lift whatsoever. That's why I'm shocked that this is working. It's just a coincidence that it's working. It is very wrong. It's working for very bad reasons. So I take the position of the plane, take the velocity vector. It'll be over here somewhere. Probably. And convert that into a screen position. And this will probably work. Oh, I should make like a cross. Like a gun cross. I'm just going to use this from Tiny Combat. This is not what this means in real life, but I'm just going to use it because I have it. Let's go back here. Whoop. I'm gonna keep calling it the water line, even. I'll call it a gun cross. That's closer to being correct. But also not correct. But it is closer. This is just static, it just stays there. And the flight path marker is here. And this is gonna show them perfectly lined up because right now they are perfectly lined up. There is no angle of attack whatsoever. This is going to be tricky. I don't actually know. There is definitely not a physically correct way to do this. I'll say that much. It's going to have to be just a magic fudge number. When in doubt, what does Jane's do? I'm going to phone in an expert here. Haha, MiG 17. No, let's... Oh, I can't say that on stream. Let's see. You think it's something as dumb as the amount of stick deflection as the amount of deflection here? No, it can't be that dumb. Wow, the 16 has a lot of alpha. I don't know that the real one will give you that much alpha. No, it's not that dumb. Because if I do this, yeah. I think it's probably related to rate, though. Oh, wait, is there a side slip? Yeah, there's a side slip. Huh. I'm pretty sure this is variable, too, because this is just the F-16. What's something really tight? Something old, probably. How about the Phantom? Look at this awesome heads-up display for an F4B. Maybe it's related to G. No, maybe it is related to G. No, but then what's the side slip coming from? Oh, that's the guy in the back. It does seem related to the turn rate. So if I slow down, I'm gonna make more G. Oh, G went down. I think it's related to G. No, but it might be turn. I don't know. Let's see, I need to go fast. See how it's picking up speed? Oh, right, no gun. I think it's just related to turn rate. And it might not be on purpose, it might be something else. Does slip? I can't do it on this stick. I keep getting roll when I do that. If I roll, does it slip? I can't tell if that's me or not. Hmm. It seems like it does a little bit. Hmm. So I have an idea. I don't know how accurate this is. Why do I keep wanting to shoot the gun but doesn't have one? Pew. Oh, no sparrows. Pew. Look at it go. What's the key for bombs? There it is. Oh, yeah. Look at that. Wow. Why? Why even model it like that? Why even model it like this? This seems like so many more polygons than just make it a cube. Weird. Maybe it's not supposed to be like that. I mean, the geometry is really jittery on here. Oh, look at that dithered Gorad shading. Oh, that's great. Ugh. Alright, I'm just gonna do a hacky thing. That'll probably work just fine. I am going to take the velocity vector and use good old smooth damp and see what it does. Because here, let's do current velocity. No, not current velocity. Target velocity is this. Is gonna be that. That's target velocity. And then let's do velocity is dot smooth damp dot rotate. No, I can't rotate it because it's not that. I don't know what's gonna happen. If I smooth it from the current velocity to the new velocity, I don't know what the speed should be. I'm just gonna make it a number because I really don't know what this number would be. Responsiveness? I have no idea. Speed would be responsiveness. Why was it not picking it up? And delta time. Why is that not working? Response. Oh. Responsiveness. See, the cool thing about not understanding coding is that you don't realize that I'm doing a lot of guessing. Hey! That's pretty good. For not knowing at all what I was gonna do. Do I lose speed in a turn now? Oh, that's pretty good. Look at all these happy coincidences. That's pretty good. You know what? I might just leave it at that. Okay, if I set responsiveness to 5, look how tight that is now. Oh, but I'm going so slow. Why am I going so slow? I'm going really slow. Ooh, something's not right with the speed. Maybe I need to lower drag. No, because of the... No, it has nothing to do with drag. Speed is not working right. Even though I have 0 drag. I think I know. I think it has to do with... there's something I'm doing here that is very bad. Oh, I think it's that very bad thing I was talking about earlier that was very bad, and I really shouldn't be doing. That's gonna break everything. I should do everything in forces first. So thrust acceleration. Here, that's not thrust force. This is thrust force. So let me refactor this a bit. Equals thrust force divided by mass. And then thrust is gonna be my forward time thrust force. Actually, I should call this thrust, call this thrust force. This is gonna be a vector. Vector 3. So that's my thrust force. Meanwhile, my gravity force... I'm very scared I'm gonna break everything. My gravity force is gonna be physics times gravity times my mass. Because mass times gravity gets you force. Force equals mass times acceleration. That's not right. I did not stop development on Tiny Combat. It is, it's still going. You should check my Twitter if you want to see the most up-to-date updates. Because I post less often to YouTube than I do to Twitter. I'm gonna break everything. This is super gonna break. Okay, but now I need an acceleration. And so my acceleration is gonna be... Wait, okay, so I need to get rid of this mass here. So thrust, I'm making this much thrust from the engine. The force is gonna go forwards with that much kilonewtons. This, what's a newton? What's the actual unit? That's a like composite unit. It's equal to 1 kilogram meters a second squared. So 1 kilo. Okay, so yeah, okay, so the kilograms is a good unit. I don't want to do any Tiny Combat development on stream. Not yet. There's some things I don't want to show about it yet. But we'll eventually, hopefully. I might do... Okay, but acceleration... That's your... That. Force divided by mass. So that's my gravity force plus my thrust force. Oh, I should get the drag force in here too. Drag here. Drag is square magnitude times drag, which is a magic number. Just velocity times... I'm gonna go back to not being divided by 1,000, because that's a force. And so... the drag force... That actually might be force. Man, drag is so just arbitrary. It's gonna be negative velocity dot normalize the direction of your velocity vector times the magic drag number. And that's just drag force. So that plus the drag force. That's your acceleration, but it's divided by mass. I think this is right. I hope it's right. Thrust is already being applied. Let's make sure things still work. This is gonna be messy. I'm gonna fall out of the sky. But that's right! I should fall out of the sky as I accelerate. This is working as intended. Because, like, if I rotate like this, I should fall slightly to the right now. I'm not falling to the right. Not even slightly. Let's do a hack again. I'm just gonna take... Oops. Okay. We are back to mostly working. Actually, that's cool, because the numbers I was canceling out before, I don't need to now. What was the magic number before for... Oh, drag... Oh, the drag isn't working. Is it? Oh, the drag's not working. Why isn't the drag working? It might be time to multiply by 1,000. This is meters a second score. This is meters a second. This is a number. I need meters a second squared, though. I need an acceleration out of this. Time to look up the drag force again. That's a lot of numbers. It's just a number! Ah, why is drag so magic? Oh, it is working. But why don't I accelerate? Oh, I have the throttle on 0. But I still don't accelerate. Oh, there we go. Gravity accelerates me. But thrust doesn't? What's missing? What if I multiply it by 1,000? It didn't make a difference. Whoa, if I multiply by a lot, it goes. Oh gosh, oh gosh, oh geez. I mean, I guess that proves the drag isn't working. Oh. I have broken a lot of things. This needs to work in the ideal first before I can add angle of attack back in. Which means I need, like, here, if I set 1 drag, multiply this by 1,000. I think there's something weird with the units going on right now. See if I put, okay. There's something weird going on with the units. Yeah. Weird. Because this is in kilonewtons. Oh, is it expecting newtons? Oh, because, what is it? A newton is kilograms. I'm gonna multiply by 1,000. I'm gonna do it. I'm gonna convert it from kilonewtons to newtons. Okay, sure. That does compile fast. It doesn't normally compile that fast. Tiny Combat definitely does not compile this fast. Okay, does drag work? The number needs to be bigger. 1. I want to max speed. Okay, but it seems to be working. I go down, the speed goes up. I go up, the speed goes down. I go level. Eventually, it needs to max out at something. I want it to max out at just under Mach 1. Time. Give me lots of time. That's too much. 0.7. Whoa! Oh. Oh. Need to be level. That's like about right. That's just under Mach 1. So 0.7 drags. And if I ease off the throttle, I start slowing down. Okay, so the ideal is working now, but I need to set this to 0.7. I wonder if it has to do, maybe it's because the mass is in kilograms? I'm not sure. Are the switches... Oh Oh, something happened at 4 minutes. Are the switches in Tiny Combat interactable? They are not. I've thought about it, but it's hard to come up with a good reason for them to be. I mean, it'd be cool, but it's. I can't come up with a good reason for it to happen. And it's not trivial work either. It would take a lot to get them working. Code-wise, probably not. Maybe. But it's... I've definitely thought about it, but it's hard. I can't really justify it right now. I also kind of don't really want it to be that kind of game. I don't want it to be that complicated. I totally lost my train of thought because of the switches. Oh yeah, drag 0.7. Did I do anything with multiplying drag by something? I did not. So drag of 0.7 gets me something that seems right for an F-16, or at least roughly okay. And that's my ideal velocity. But what I actually want is... So my ideal is going to be velocity, then target velocity is... I gotta basically do this code again. Times delta time. And then I want to set it forwards. Velocity dot magnitude. And then I do my smooth damp, where dot move from velocity to target velocity, the speed of responsiveness, whatever that means. I don't actually know what that means. And I guess this might work? Maybe? I don't know. I'm not completely sure. Let's do a responsiveness of 5. 5 responsivenesses. To, I don't know, 10. Sure, whatever. I'm not accelerating. Something feels wrong here. Something feels weird. It's like the drag is both too low and too high. I think it's because I think I'm changing... I don't know. The thing with okay, so the idea being, what if only the MFDs are clickable? The problem I have with that is not every plane has MFDs, and I don't want to design the game around MFDs or needing MFDs. Maybe things that kind of act like MFDs, but I don't know. I don't think I want to do that. Because if you have clickable MFDs, then I feel like I have to custom tailor too much functionality to the individual plane. Especially when, like, let's say you do a Phantom, which decidedly does not have MFDs. You can't... I don't know how I would make that work. And the kind of controls that, like, the Phantom has that are vaguely equivalent to what an MFD does, that's kind of just on the throttle or in other places. Or the guy in the back does it, I guess. But okay, I think the problem here is I shouldn't be using this. I should only be using this to rotate the velocity vectors. I shouldn't be using it. Like, I should only care about the direction. So, like, velocity should be... Because the actual magnitude of this vector needs to change instantly. I think that's the problem here. But the direction needs to be what changes slowly. So what if I do... This is kind of weird. This is very weird. This is... Ooh, this is super weird here. What if I keep track of only this? And then here, I do velocity. Let's see. I actually modify it. I don't want to change the direction. But that's the force? I actually don't... I don't know how to do this well. What did I do for... Okay, let me take a look back here. Because I definitely do some weird stuff with modifying the velocity vector. Oh, see? I have a velocity direction. I was right. Or, I did come to the same conclusion. Oh, interesting. What am I rotating? Okay, so I have a velocity direction that starts forwards, rotates down. Oh, this is because of landing speed stuff. Oh my gosh. I tied alpha to G. I tied alpha to G. I tied alpha to G. Oh, that's so weird. That's super weird. Oh, that's super weird, but I think I get it. Huh. Okay. Well, here's what we do. We have a forward velocity, And that's your... Okay, velocity stays the same here. This is your forward velocity, which is kind of your, like, platonic ideal of velocity. And then you have your modified velocity direction. It's forward, but you deflect it down. Wait, but what about the side slip? I don't think there's side slip in this. I think I just didn't do side slip. Rotate towards up? Oh, that makes sense. Oh, that makes sense. That's weird, but that kind of makes sense. Oh, this is super weird. Which is your forward velocity, but I want to rotate it down. Is there a transform it down? No, there isn't. And let's, for now, deflect it by the pitch G. This is so hacky. This is so weird. No. Degrees to radians. And then this thing, which I don't know. I still don't know what that means. And so what you actually get is velocity dot magnitude times that. Oh gosh, if this works, I'm gonna be slightly annoyed. Whoa, that's not working. Whoa, can I rotate? Yeah, that didn't work. That didn't quite work. This should be a normalized number. That's what was happening there. But it's 1. Am I turning? I am turning. This is working? Ooh, this gets spicy. Oh, this is very spicy. This doesn't make any sense. Now we're dipping into old video game programming territory, where you just write things and they don't really make that much sense. But they get good results. So, wow, it's late. How long has this been going? Oh. When did I start? I started at 5. 5, 6, 7, 8. Oh, that's almost 4 hours. I should probably stop soon. Yeah, I'll probably stop at 9. At whatever I've got. Maybe I'll continue this next week, or I don't know. I might continue this next week or something. But my spicy display velocity here is going to be velocity direction times velocity dot magnitude. Oh gosh, this is super bad. This is so bad. I feel bad about this. Oh my gosh. What does this look like? Oh, of course it would look like that. Oh, that's so bad. This is actually kind of how F19 works. Actually, this is a lot like how F19 works. Oh gosh, that's bad. Wait, why am I getting negative G? Well, oh, this is bad. This is a bad solution, and you should feel bad. No. No, 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 no. No. Oh my gosh. This is so bad. Why can't... Okay, I should be able to make what I was doing before work, because that seemed to work. It's just that the magnitudes were wrong. So I need to be able to do what I was doing before, but with the right magnitudes. Because the problem I was running into is... Okay, let me set it up to how it was before. So you have your... Okay, there's a target velocity, which is your kind of ideal velocity. And you take that and you add your accelerations. You gotta do delta time. And then, instead of taking just that, you do the smoothing. So you start with your own velocity and you smooth it towards the target velocity. And you do it at the speed of responsiveness. And the thing is, this works. Let me delete all this because this is not needed anymore. The thing is, this works for the direction. This works really well for the direction. So you get something that looks... I hope I did this right. Oh wait, I need to comment something up. Get rid of that, because that's super wrong. And then in here, this should be velocity. Okay. So this works... Why is it going down? Oh, because I didn't do something. I didn't do my Platonic ideal of velocity. Equals velocity dot magnitude times velocity dot forwards. I think I need to separate speed from velocity somehow. But that's weird because it's all vectors and you can't really separate them. Okay, so look at that. That looks great. I like the way this looks. It's very simple, very easy. But the problem is changes in velocity, like, wait a second, it's working. Uh-oh. Something went right. Uh-oh. Something went right. Why did something go right? Let's see. I bet you if I do this, I start becoming less responsive to change in speed? No. I lose speed more in a turn. And if I boost this, I lose almost no speed in a turn. Wow. fact, I can probably gain speed in a turn. That's realistic and... Huh. 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 Hmm. Something went horribly right, and I'm not sure what or why. You know what? This kind of feels like Project Wingman. No, but this also isn't quite working the way I want it to. What do you mean by bullet hell mechanics? I have thought a lot about what a 3D bullet hell might look like. But it's hard to do because you don't have depth perception. That's the real problem with 3D bullet hells. There was a really interesting back when VR was first new. Somebody made it was actually a Toho game. It was kind of a 3D bullet hell game, but but you had a VR headset, and because it was 3D, you have that depth perception, and it made it a lot easier to dodge bullets. Because on a flat screen, you don't have that, and that's it makes it really hard to tell where the bullets are. That's why bullet hells work so well in 2D, because your quote unquote depth is just the vertical axis on the screen, or horizontal if it's a side scroller. I think the way a bullet hell probably would work is with the camera locked towards wherever the bullet's coming from, and then you fly either like your WASD moves you forwards towards the target, and then like A and D moves left and right, or you have kind of Hawks style like RC plane kind of controls. Well, it's still just regular airplane controls, but you're controlling it from third person, and I don't know, some people have problems with that. I don't know. I'm not sure it's a good idea. This kind of works well. There's one specific thing this doesn't do that I want it to do. And it's that if I point the nose level, I want the flight path marker to be on the dot. I don't want to be losing altitude right now. Which I know that's... What it's doing right now is realistic, but I don't want it to be realistic. What happens if I slow down? I bet if I slow down, the flight path marker will drop. Maybe this is okay. So, I have thought a lot about what a bullet hell, but with like airplanes, might look like. And I'd like to try it someday. I don't think it'd be good. I think it'd be interesting, though. This really doesn't want to slow down. I need air brakes. I guess I can turn to slow it down more. Man, look at all these things that happen by accident. Yeah, see, as I slow down, the flight path marker drops more. I would say this would work well if you'd never had to land. And you didn't really care about stall. What happens if I stall? Actually, I know what's going to happen. The flight path marker is going to drop, and I'm going to start falling. Yeah, I'm falling right now. But if I do this, I'll be totally fine. If you never had to stop, I think this could be really good. Like, this is not Jane's quality, I don't think. But this would be good enough for, like, an Ace Combat kind of game. Because in Ace Combat, you never have to land, except for a handful of them. 6 is the only one I think has landing as part of the missions, and not as like a cutscene you do. This works, but I don't like it. It's one of those things that it feels good. It's what okay, this is one of those things that I would tell people to use because I think this feels really good, but it bothers me, and I wouldn't use it. Like if I played a game made by somebody else and it controlled like this and it had like real planes and it was trying to be sort of halfway kind of like a little like a notch above Ace Combat realistic, I would think this is great. And I would congratulate them on having the quote-unquote bravery to not put too much effort into their flight model and just make the game fun instead. But unfortunately, I hate fun. So for anything I make, this is a little too fun. I need to make it worse. This kind of feels like Project Wingman, actually. Because that game also has a really floaty, very indiscriminately floaty flight path marker. No G limits, though. I bet you if you put a G counter in Project Wingman, you'd be easily doing like 20 G. Oop. Okay, so you could add... Okay, let me read this out. You could add a restitution value, so the less G changes, the more centered it is. I think that would be like changing the responsiveness. Like, okay, if I'd make this... Yeah, look how centered that is. So if the responsiveness changed based on G, so I'm doing 1G now. And so I set responsiveness to 10. I am maximally responsive. But let's say I do a 7G turn. Then I drop it down to... Whoa, that's way too little. That's way too small. Drop it down to 1. That might work. That might work. Oh, you know something else this doesn't do that I totally forgot? When I bank, I still don't, you know. I don't go that way. I don't turn. There's no way to do a level turn while banking. Like, I can just do this, and I won't go anywhere. I mean, you wouldn't go anywhere in real life, but that's... Yeah, that's one thing I missed. How did I know I had something like that, but I commented out. It's not used in Tiny Combat, in the AI physics. Oh, it's just magic. Wow, it is just magic. That is, okay. I think Ace Combat does this. It's a good solution, I think. Where the more you're banked, it just automatically does rudder input. I mean, probably like fake rudder input, but it's basically rudder input. And that works pretty well because then you start sliding like this. And if you want to do a level turn, you have to give it a little bit of positive stick. And it's not a big deal, but it's something. I think Ace Combat does that. And I think... I used to think that's what Jane's does, but I think it might do something else now. I think it might do something connected to G. Because the 1G in Jane's is so suspicious. So I have something. It works. It's honestly not bad. Like I said, I would be totally okay if somebody else used this in like a simple flight simulator. Imagine if you had the giant... Oh, okay. One more thing I want to try. What if I add a scale value? What if you wanted to do the Jane's thing, where the scales are completely screwed up? So every time I do this, times scale. So if I run the game at half scale, so here, I'm going to fly, and I'm going to set to half scale. Okay, so I'm going to set this at like half scale. And now, or let's do a quarter scale. Let's go really big. Now you kind of get that effect in Jane's where everything is going super slow. Even though your speedometer says you're going 500 knots, it looks like you're going nothing like that. Like, look how fast that's actually... Actually, that does look like Jane's. Look how slow that is. I think Jane's is slower. So now you can have your pretend 500 knot dogfights pulling 7G. Oh yeah, you're super G limited. You can have your 500 knot dogfights pulling 7G, but you're actually doing it in this tiny little box. And then you can add gigantic hitboxes, and it'll be just like Jane's. Any plans to add semi-realistic radar? For Tiny Combat, I have a lot of thoughts on what I want to do with the radar. I don't know how much more I want to say than that. I will say that there is no real radar in the game right now. Well, okay, there was a radar in the game, but right now there is no radar in the game. The Harrier doesn't have it, and there's no SAMs right now in the game that would use it. So I'll probably develop radar at the same time I start working on SAMs. And I have a lot of ideas on what I want to do with radar. It's not going to be... It definitely won't be like DCS. I mean, you could say that about basically anything in the game. But I do want to have some interesting mechanics to it. I have thoughts. I don't want to get into it more because I don't want to make promises, which I'm not going to make promises, but people will interpret as promises and things get out of hand, and I don't want to do that right now. But I think I'm going to call it here. This works. I don't like it. I don't like that I don't like this. This does work, though. Put this scale back on 1. Less floating point problems if your scale is tiny like that. Like, this is fine. I think, honestly, I'll probably come back to this. I might do another one of these next weekend. What's next weekend? I might want to do one of these next weekend and continue to work on this. I might work on this off stream. Maybe I won't do anything at all. Either way, this will definitely show up on GitHub at some point. There's really nothing to clean on it. I have to clean up this terrain stuff here because I was doing some funny things with terrain earlier. But otherwise, aside from throwing a README on it, I really don't have to do much to upload this. I wonder if I make 2 branches just in case. Like one with the current physics, and then one with worse physics when I get to it. If I do. That way people who want this kind of stuff to use it for reference, they can. And this works pretty well, honestly. Like I said, I would be totally happy to see this kind of thing in another game. Because you have G limits, which is pretty unusual for a flying game. You have gravity, like I go up and my speed goes down, I go down, my speed goes up. There's no way to bank, like do a level turn, like a banked level turn. You kind of have to artificially induce it. That's really the only major problem. There's very specific things about how this works that annoy me. And they mostly have to do with, honestly, they mostly have to do with writing AI. Like, it's so much easier to write AI if you can guarantee that the flight path marker is directly ahead of you. That's a big deal. Because if you have, like, say if it's like this and the flight path marker is below the thing, what you then have to do is you have to make the AI fly with their velocity vector, which you can do, but it's not responsive. It works kind of in cruising, but it just creates a lot of issues. It's one of the reasons that I switched to a very unrealistic. Well, it's not very. It actually uses some of the real code, but it's one of the reasons I made a separate flight model for the AI for Tiny Combat, because it was just getting too much of a problem. Also too expensive computationally. Too much of a problem to have to deal with all these things. And the AI still uses the same drag formula as the players. They still use the same engines as the players. They share a lot of code with the players, but the way they turn and the way they fly is a little different. I cheated though with that one because I used physics, and I had to use physics because they're using the same engines as the player, like and the same drag model as the player, which needs the Unity physics. But yeah, this was good. I think I will play maybe a couple rounds of Jane's and then close it out. Because that game is... that's a real good one. Let's see. I don't even know what a AIDC... It looks Chinese. I don't want to say it. What is this? Oh, I have to get my joystick. Is this the FCK1? But like the 90s version of it? What is this? It has American weapons, whatever it is. Oh, they're helicopters. Oh, they fired a missile. Oh my gosh. Oh my gosh. Helicopters are no joke. Wow. Oh my god. Helicopters are dangerous. I only have two Sidewinders. I love how your guy talks. He's great. Follow the tracers. Oh, I wasn't locked. See, look at this. I have to slow down so that I can pull more G. Oh, oh man, look at those forgiving hitboxes. Wow, helicopters are dangerous. This one also has great textures. This is definitely a newer model. Wow. This is Jane's Fighters Anthology, which is the last of the classic Jane's games. This is basically all of them put together. And the nice thing about Jane's Fighters Anthology is that it runs on modern PCs just fine. It's the only one of these that runs just fine on modern PCs. All the other ones are complicated. You're going to have to go through emulators or virtual machines or things like that. Look how arcadey this is. It's so good. Ooh, that was close. Whoa. Look at this. This looks like a space sim. Oh, I might not make this. I'm not gonna make it. Engine's damaged. Ah, these Su-25s. Have to eject. Ah, what a good game. That's hard. Oh, I think the game crashed. Oh, I made it. Alright, that is it. Thanks everybody for showing up. That was fun. I'm surprised I got as much done as I did, because I was really ambitious on my list of things to do. Alright, see you all later. I might do one next weekend, maybe. I'm not sure. Depends what happens. Depends what happens with the uh, other stuff. Cool.